Today we'll discuss a general method with which we can find condition of tangency, the equation of tangent, and point of contact for circle, parabola, ellipse, and hyperbola. So using this method, you can find it for any of these four conics. Now before learning the method, there are two prerequisites that we must know. And the first one is, suppose we have any conic whose equation is y equals fx, and we have a line which is y equals mx plus c. Now we know that this conic and line, they may intersect at 2 points, or they may touch each other, or they may not intersect each other. So what we'll do is, if we have a conic y equals fx and this line y equals mx plus c, we'll find their points of intersection. Now for points of intersection, we'll eliminate one of the variable. Suppose we'll eliminate y. So we'll put y as mx plus c. So we can write this as mx plus c equals fx. Now this equation will be a quadratic equation in x. Now when this line is a tangent to this curve, in that case there should be only one point of intersection. That means this quadratic equation should give us only one real root, and this is only possible if d is equal to 0. So for condition of tangency, what we are going to do is, we are going to eliminate y, we'll find a quadratic equation in x, and for condition of tangency, we'll simply put discriminant equals 0. So that's your condition of tangency. And once we have condition of tangency, we'll get the value of c. And if we put this c in equation of the straight line, we'll get equation of tangent. So this is how we're going to write condition of tangency and equation of tangent. Now for point of contact, we'll need to learn something else. So suppose we have this curve and this line, it is tangent to this curve at this point P, and say this point P is x1, y1. Now in this case, this point P is point of contact. Now fundamental here is, if this P is point of contact of this tangent, then equation of tangent is given by t equals to 0. Now the question is, how do we find t equals 0? So we are given equation of this curve, and which is say s equals 0. So we will be given this equation of curve or this conic. So in this equation, what we need to do is, we need to replace x square with x into x1, y square with y into y1, x with x plus x1 upon 2, and y with y plus y1 upon 2. And if we substitute all of these in this equation, we'll get equation of a line, and that equation is t equals to 0, which in this case is equation of tangent whose point of contact is p x1 y1. In order to illustrate better, I'll take up an example where we're going to write t equals 0 from s equals 0. Suppose we have a circle which is x square plus y square plus 2x minus 4y minus 1 equals to 0, and we have this point P which is say x1 y1. Now this equation is s equals 0. From this equation we have to write t equals 0. And how do we do that? We'll replace x square with x into x1, so it will be this x into x1 plus, we'll replace y square with y into y1 plus, now this is 2 into, we change x with x plus x1 upon 2, so it will be this x plus x1 upon 2 minus 4, and y is y plus y1 upon 2, and minus 1 equals to 0. So this equation, which now is equation of a line, is t equals 0. So this is how we write t equals 0 for any conic. Let us take another example. Suppose we have this s equals 0 as this parabola x square equals 4y plus 3, and the point here is 2, 3, and we have to write t equals 0. So for t equals 0, we'll replace x square with x into x1, so it will be this 2x. Now for y, we'll write y plus y1 upon 2. Now here y1 is 3, so it will be this y plus 3 upon 2 and plus 3. So this equation is t equals 0. So this is how we write t equals 0. So these are the two prerequisites that we must know. Now we'll begin our discussion with equation of tangent to a circle. Now suppose we have this circle whose equation is x square plus y square equals a square. Center at origin and radius equals a. So we have this circle with center at origin and radius equals a, and we have to find condition of tangency to this circle. And suppose this line is y equals mx plus c. So we have this curve and this line. So first we'll find its point of intersection. So we'll replace y with mx plus c. So we can write this as x square plus mx plus c whole square, and it is equal to a square. Now we'll write this as a quadratic equation in x. So it will be this 1 plus m square into x square plus 2 m into c into x plus c square minus a square equals 0. Now since this line, it is a tangent to this circle, there should be only one point of intersection, and it is possible if and only if this d is equal to 0. So this quadratic equation must have equal roots. So if we put d equals 0, we'll get this as 4 m square c square minus 4 1 plus m square into c square minus a square equals 0. We'll cancel this 4 with 4. So it will be this m square c square minus c square minus m square c square plus a square into 1 plus m square equals 0. Now this m square c square will cancel. So from here we get c square equals a square into 1 plus m square. So condition of tangency is this line y equals mx plus c will be a tangent to this circle if c square is a square into 1 plus m square. And once we have this condition, we can also write equation of tangent. Now equation of tangent for this, it is y equals mx plus c, and c is this value. So it will be this plus minus a under root 1 plus m square. So using this quadratic method, we can find condition of tangency as well as equation of tangent for any conic. Now we need to find point of contact. So we have to find this point. Now suppose this point is x1 comma y1. Now we need to find x1 and y1. Now we already know if point of contact is x1 y1, then equation of tangent, it is given by t equals 0. And how do we find equation of tangent? Now this is our equation, s equals 0. So wherever we have x square, we write this as x into x1. So it will be this x1 plus, and in place of y square, it will be y into y1 minus a square equals 0. So equation of tangent is x1 plus y1 minus a square equals 0. And this first equation, which we have in terms of slope, we can also write this as mx minus y plus minus a under root 1 plus m square equals 0. Now these two equations, they represent the same tangent. So basically these two lines, they are coincident. That means a1 upon a2 must be equal to b1 upon b2 must be equal to c1 upon c2. So from here we can write x1 upon m will be equal to y1 upon minus 1 and will be equal to minus a square upon plus minus a under root 1 plus m square. Now here we'll cancel this a with a. So we can write this x1 as plus minus and then minus am upon under root 1 plus m square and this y1 will be plus minus a upon under root 1 plus m square. So this point of contact P will be plus minus, and then this is minus am upon under root 1 plus m square, and this is a upon under root 1 plus m square. So this is how we find condition of tangency, equation of tangent, and point of contact. Now the result which we have for this circle with center at origin can be generalized. So we know that if circle is x square plus y square equals a square, then equation of tangent, it is given by y equals mx plus minus a under root 1 plus m square. And if we have any general circle which is x minus h square plus y minus k square, and it is equal to a square. For this, what we'll do is we'll take x minus h as capital X and y minus k as capital Y. So we'll write this as capital X square plus capital Y square equals a square. Now it is same as this first form. So we can write equation of tangent as capital Y equals m times capital X plus minus a under root 1 plus m square. Now we'll replace y with y minus k. So here it will be this y minus k equals m, and this x is x minus h. So it will be this x minus h plus minus a under root 1 plus m square. Now we look for condition of tangency for this parabola, which is y square equals 4ax. Again we have this tangent y equals mx plus c. We'll replace y with mx plus c. So it will be this mx plus c whole square equals 4ax. So now this is m square x square plus 2 m into c minus 4a into x plus c square equals 0. Now again this line, it should be a tangent to this parabola. So there should be only one point of intersection. So again we'll put d equals 0. So we'll have 4 mc minus 2a whole square minus 4 m square c square equals 0. Now this 4 and 4 will cancel. So we can write m square c square plus 4a square minus 4a m into c minus m square c square equals 0. M square c square will cancel. This 4a will also cancel. So we get c as a by m. So condition of tangency is c equals a by m. And once we have c, we can write equation of tangent. Now equation of tangent is given by y equals mx plus c, and c is a by m. So for this parabola, equation of tangent is y equals mx plus a by m. Now we have to find its point of contact. Now suppose this point P is x1 y1, and we know that equation of tangent is given by t equals 0. Now for t equals 0, we'll replace y square with y into y1. So it will be this y into y1, and 4a, this x is x plus x1 by 2. Now this 2 and 2 will cancel. So we can write this as 2ax minus y1y plus 2a x1 equals 0. And we know that this equation, it must be equal to equation which we have got from condition of tangency, which is m square x minus my plus a equals 0. Now both the lines, they represent the same tangent. So from here we can write 2a upon m square, it is equal to minus y1 upon minus m, and it will be equal to 2a x1 upon a. This a and a will cancel, minus and minus will cancel. So we'll get this x1 as a by m square and y1 as 2a by m. So this point of contact will be a by m square comma 2 a by m. So that is the result for parabola. So we have condition of tangency, equation of tangent, and point of contact. Now this third one, we have to write it for ellipse. So we have this standard ellipse, x square upon a square plus y square upon b square equals 1. Now suppose this line is y equals mx plus c. We'll write this as x square upon a square plus mx plus c whole square upon b square. It is equal to 1. Now this is b square x square plus a square m square x square plus c square plus twice mc into x, and it is equal to a square b square. Now we can write this as a quadratic equation in x. So it will be this b square plus a square m square x square plus 2mc a square x plus a square into c square minus b square equals 0. Now again b equals to 0. So we get 4 m square c square e to the power 4 minus 4 b square plus a square m square into a square c square minus b square equals 0. Now we can cancel this a square. So it will be this a square here and this 4. So we can write this as m square c square a square minus b square c square plus b to the power 4 minus a square m square c square plus a square m square b square equals 0. Now this m square c square a square will cancel. So from here we can write this c square, it will be a square m square plus b square. So that is a condition of tangency. And if we have condition of tangency, we can write equation of tangent as y equals mx, and this c is plus minus under root a square m square plus b square. So that's your equation of tangent. Now for point of contact, suppose this point is x1 y1. We know that equation of tangent is given by t equals to 0. So this x square will be x1 upon a square, y square is y1 upon b square minus 1 equals 0. And this equation, it must be equal to equation of this tangent. So this is mx minus y plus minus under root of a square m square plus b square, and it is equal to 0. Now again we write this condition that both the lines, they represent the same tangent. So we get x1 upon a square m, y1 upon minus b square, and it is equal to minus 1 upon plus minus a square m square plus b square. So here this x1 will be plus minus and then minus a square m upon under root a square m square plus b square, and this y1 will be b square upon, and this is plus minus under root a square m square plus b square. So this point of contact will be this plus minus minus a square m upon under root of a square m square plus b square, comma b square upon under root a square m square plus b square. And for this hyperbola, x square upon a square minus y square upon b square equals 1. We know that almost all the results of ellipse can be transformed into the results for hyperbola if we replace b square with minus b square. So for this hyperbola, condition of tangency, it will be c square equals a square m square, and then in place of b square we'll write minus b square. And this equation of tangent, it will be y equals mx plus minus under root of a square m square minus b square, and this point of contact will be plus minus, and this is minus a square m upon under root of a square m square minus b square comma minus b square upon under root of a square m square minus b square. So this is how we find condition of tangency, equation of tangent, and point of contact for circle, parabola, ellipse, and hyperbola. So now what we'll do is we'll compile the results. So if we have this circle, x square plus y square equals a square. Equation of tangent is y equals mx plus minus a under root 1 plus m square. And this point of contact is given by plus minus ma upon under root 1 plus m square comma a upon under root 1 plus m square. So this is for your circle. Now for this parabola, y square equals 4ax. Equation of tangent is y equals mx plus a by m, and point of contact is a by m square and 2a by m. For an ellipse, x square upon a square plus y square upon b square equals 1. Equation of tangent is y equals mx plus minus under root a square m square plus b square, and here point of contact is plus minus a square m upon under root of a square m square plus b square comma minus b square upon under root of a square m square plus b square. And finally for hyperbola, x square upon a square minus y square upon b square equals 1 will be this y equals mx plus minus under root of a square m square minus b square, and point of contact will be this plus minus a square m upon under root of a square m square minus b square, and then we'll replace minus with plus, so it will be this b square upon under root of a square m square minus b square. So this is the result that we have. Now there is this 2017 JEE Advanced question. So it was this table where we are given these three columns, column 1, 2 and 3, where we need to match curve with its tangent and its point of contact. Now this is the circle x square plus y square equals a square. Now we know that its tangent is y equals mx plus minus a under root 1 plus m square. So it'll match with this second. And for circle, point of contacts are minus am under root 1 plus m square comma a upon under root 1 plus m square. That means it matches with q. So first matches with second and it matches with q. Now this third one is parabola, and we know that equation of tangent to parabola is y equals mx plus a by m. That means this third, it matches with 1 and its point of contact is a upon m square to a by m. So it will be this p. Now the second equation is equation of an ellipse with a square and 1. So here in this case, value of b is 1. And we know that equation of tangent is y equals mx plus minus under root a square m square plus b square. So it will be y equals mx plus minus a square m square plus 1. So that means this second will match with fourth. This second will match with fourth. And here point of contact, it is given by a square m upon under root a square m square plus 1. So it will be a square m upon under root a square m square plus b square and minus 1 upon under root this. Now for point of contact, we have this plus minus sign, and then it will be this plus minus a square m upon under root a square m square plus 1, and this is minus 1 upon under root a square m square plus 1. Now if we take plus sign, we don't have an option. If we take minus sign, then it will be this minus a square m upon under root a square m square plus 1, comma 1 upon under root a square m square plus 1. So that means this second, it matches with 4 and it matches with r. And this fifth one is a hyperbola, and for this hyperbola, we'll replace b square with minus 1. So here it will be this third option, and if you put b square as 1 here, taking this minus sign, it will be this option S. So this is how we can simply match curves with their equation of tangent and their point of contact. Now this first question is the tangent to a suitable conic at this point, say A, root 3 comma 1 by 2, it is root 3x plus 2y equals to 4. So here we have this conic, and tangent at root 3 comma 1 by 2 will be drawn like this. Now for parabola and hyperbola, tangent will have positive slope. So it cannot be a parabola or a hyperbola. So it can only be a circle or an ellipse. But in case of a circle, equation of tangent will be x(x1) plus y(y1) equals a square, where point of contact is x1, y1. So in that case, this equation will be root 3x plus 1 by 2y. So it cannot be this circle. So it has to be this ellipse. So this point, it should lie on ellipse. So answer should be second, fourth and R. That's your option D. Now we'll prove it also. Now if we have this point will lie on this ellipse. So we'll get 3 plus a square by 4 equals a square. So value of a square is 4. That means value of a is 2. So equation of this ellipse will be x square plus 4y square equals to 4. Now equation of tangent is given by t equals 0. So there will be root 3x plus 4 into 1 by 2y equals 4. So it will be this root 3x plus 2y equals 4, which is this given option. Now we have to verify this point of contact. This minus a square m. So this is minus 4, m is minus root 3 by 2 upon under root of a square m square plus 1. And this is a square m square plus 1. Now this is root 3 comma 1 by 2. So that means this one, it matches with D. Now the second one is, if tangent to a suitable conic is found to be y equals x plus 8 and the point of contact is 8 comma 16, then which of the following option is the correct combination? Now in this case, it has to be either this parabola or this hyperbola. So for this second question, we know that this point is 8 comma 16 and it is y equals x plus 8. Now in this case, value of m is 1 and this parabola is y square equals 4ax. So first we'll check for this parabola. Now this is 16 square and this is 16 into 2. So value of a is 8. And we know that equation of tangent is given by y equals mx plus a by m. That means this is the equation of tangent, and point of contact, it is given by
a upon m square and 2a upon m. So it will be this 8, 16, which is this given condition. So it will be this parabola. Third, it connects with 1 and p. So it will be 3, 1p. And that's your option A. And the next one is for a equals root 2, if a tangent is drawn to a suitable conic at the point of contact minus 1, 1, then which of the following option is the only correct combination for obtaining its equation? Now, if we put x as 1 and y as 1, then we should get a as root 2. This is only possible in this case of a circle. So this third one, it should be this 1, 2 and q. And that's your option D. Now in this case, since a is root 2, equation of this circle is x square plus y square is equal to 2. Point of contact is minus 1, 1. Equation of this line is x plus y equals to 2. And the value of m is 1. And if we put a as root 2 and m as 1, so here root 2 will cancel. So this is minus 1, 1, which is a given point. So the correct options are D, A, D.